The gold medal is the premier award of the engineering profession and is awarded only when there is an outstanding candidate. This is OSPI's highest honor, recognizing conscientious commitment to public service, as well as technical excellence and outstanding professional leadership. The recipient of this year's gold medal is Dr. George Xu.
My name is George Xu. I'm the professor and the Tier 1 York Research Chair in Space Engineering and Artificial Intelligence in the Department of Mechanical Engineering at York University. I was born in Shanghai, China. I came to Canada in 1993. I joined the U of T as a postdoctoral research fellow. Then I went to the industry. It's a company called Curtiss-Wright. We design and build Navy equipment to help helicopter landing on the small ship. In 2006, I joined the York University in Earth and Space Science and Engineering. My current work is related to the technology development for space engineering with a specific focus on the space debris removal and future technology like partial space elevator and electrosolar wind sail for deep space exploration. In 2009, there was a wake-up call. At that time, one working U.S. satellite collided with Russian's dead satellite and generate thousands of fragments. The collision between the satellite is a big event. People think, the space is so huge, it can accommodate a few thousand more pieces of debris. But the trend of the space debris, because more and more countries enter into the space industry. Instead of just a few satellites, now we have dozens. We are currently in the space robotic lab. The robotics behind me is artificial intelligence enhanced robotic technology. It can identify space debris using the camera on top of the hand and then tracking its motion and detect its relative position to the hand, and then automatically guide the hand to capture the space debris. And we use the active gravity compensation technology to mimic the zero gravity environment. And in this lab, we have two robots. One robot holds the robotic hand to simulate the capture motion. The other robots capture a mock-up satellite. We train our computer vision to recognize its shape. In this lab, we tested a very expensive robotic technology to capture space debris. It's a big system. But there's another approach. We want to use small space robotics. It's cheaper, quick to make, but forms like a swarm, like ants. They will look each other and we detect the satellite and then form a swarm to capture it. 3D printer has been used for two purposes. First is to making some experiment features like this mocked up satellite. We also study the possibility to making the satellite the orbit. Once in the orbit, the space structure don't have to be so strong because there's no load. In the future, we envision we only need to send raw material. The CubeSat technology refers to a very small satellite. The CubeSat makes it possible for university to design and build and launch a satellite. Over the past 8 years, we designed the two CubeSat missions. The first one, the mission purpose is to validate the technology we call electrodynamic propulsion technology, which doesn't use any chemical fuels. And after that satellite, we start a second CubeSat mission to detect the melting of permanent frost in northern Canada. a gold medal recognizes my past achievements. But I think it's also something which can push me forward, continue to excel and achieve more.
For his work in space engineering and additive manufacturing, Dr. George Xu is a very worthy recipient of this year's gold medal.